This question is slightly different than the previous two, but we can still use the same methods to solve it. So in this one, we're given a coordinate system to use. X to the right, y up. And there's two forces that are being applied, FA and FB. Now FB, we know its magnitude is 800 newtons. And we also know its direction is 30 degrees below the x-axis. However, the other force, FA, we don't know its magnitude, nor do we know its direction. But we can still represent it in our picture. So theta is measured from the y-axis and a magnitude of FA. However, now in this problem we do know already what the resultant is, because they tell us that the resultant is to be directed along the x-axis, so we know its direction, and we know its magnitude is to be 1250. So now we do know things on the right side of our equation, and we don't know something that's on the left side of our equation. However, the equation we're going to make is going to be identical to what we saw before. The resultant is still the sum of the two vectors on the left-hand side, FA and FB. So we're going to use the same method as we used before. We want to break these vectors down into their component form. So we can write, I'll start with FB. Breaking it down into its components, we're going to have 800 cosine 30 I plus 800 minus 800 sine 30 j. The j term is negative because FB points down. It's in quadrant 4, so a negative y, a positive x value. So we can write this in decimal form. We're going to have 693i minus 400j. And this is in newtons. So where it's different than we saw in the last two examples is how we write FA. FA, we don't know its magnitude or its direction, but we can still write it in its component form. We can still write that FA is going to be some x component, I'll call it FAX, in the I direction, and because it's in quadrant 1, they're both going to be positive, so some y component, I'll call it FAY, in the j direction. So again, we can break FA into these parts even without knowing everything about them yet. So this is FAY, and then this is FAX. So we'll be able to find what these are because we actually have written FA, we've written FB, and actually in this problem we can write what R is because we know that R is only in the x direction and we know its magnitude. So we know it's 1250I plus 0j newtons. So actually we can put this all together at this point. Using this equation, we know all three parts of it, so let's put it all together. So our left-hand side, 1250I plus 0j equals FA is FAX in the I plus FAY in the j plus FB, which we found to be 693 in the I minus 400 in the j. So it looks like we have, there's two things we don't know, FAX and FAY. So it looks like there's two unknowns, but only one equation. But really, this is a vector equation. It has I and j components. So all of the I components have to equate to each other, and all of the j components have to equate to each other. So if we only equate I components, we get 1250 is FAX plus 693. And if we take only the j components, we'll get that 0 is FAY minus 400. We now have two equations, two scalar equations for our two unknowns. which we can now solve. So solving the first equation up here, FAX is 557 newtons. And solving our second equation, FAY is a positive 400 newtons. And from the picture, we should expect that it is in quadrant 1. So the question, though, asks to find the magnitude of FA and the direction theta, which is measured from the positive y-axis. I'll redraw that quickly here. So what we can do, now that we know the components of FA, again, we know that in the x, it's now 557, and we know in the y, it's 400. So its magnitude first is easy to find. So the magnitude of FA, just using Pythagorean theorem, 557 squared plus 400 squared, and the square root of that, we get 686 newtons. Now they want us to find that theta as they want it measured from the positive y-axis up here. So to do that, since I already made this triangle, I'm just going to find this angle first, and then I know that beta and theta are going to be complementary angles. So I can find that beta is going to be the arctangent of the opposite over the adjacent, 400 over 557. So that angle beta is 35.7 degrees. However, again, we want theta, which is the complement to beta, so it's 90 minus beta, which means that that value of theta is going to be 90 minus 35.7 is going to equal 54.3 degrees.